I'm Zach Schrack. This is Lab 4, Oscillation. Introduction. The purpose is to study and apply the energy principle to model oscillations in a spring mass system. The models we used is energy principle equations, position and velocity update formulas, and the spring force equations, as well as the gravity equation for force. Here is the change in potential energy of gravity. Here's the change in potential energy of spring. And this is the energy principle. What's to come, this is what the code looks like after it is run. Part 1, tracker. In video analysis stage, we were given a video and we tracked it using software. The graphs to the right are the x and y displacement of the mass at different times t. As you can see, they're sine waves or cosine waves, and they are pretty stable throughout the entire thing. The y is clearly damped a little bit because it's not a perfect system, as well as the x is just not as visible. The period around the estimated period for the x is about 1.64 seconds, and the estimated period for the y is about 1.5 seconds. Part 2, computational model. Here's the code. The initial conditions are as shown up here. This is the spring properties of the spring. This is the calculating the initial energies. These are ball mass, ball position, ball velocity, gravity constant, spring constant, relaxed length of spring. The yellow is setting initial energies. The green is finding forces on the mass, including gravity, spring, and then Fnet. The teal is updating position and velocity right here with the position update and velocity update formulas. The blue is updating the spring properties like the stretch length, and L hat. And then the purple is updating the energies with new values, as well as, and yeah. What does it mean? Here's the video of the code running. As you can see, the red is the actual and the blue is the model. The red is roughly following, but it's obviously not perfect. But in this model, this is what does it mean? Part 2. In our model, the energy principle is satisfied because all the energy is converted from kinetic to potential and back and forth in one way or another without losing any energy. In the real-life experiment, energy is lost to the surroundings, either to air resistance causing heat or the damping of the spring itself also causing heat. But the entire energy principle includes internal energy, and if you include the air as part of the system, then no energy is lost, and it still follows the energy principle because it's a law. Why do we use these models? We can use the energy principle because it is the simplest and easiest way to calculate change in velocity and energy. We could use kinematics, but it would take much longer, and the focus of this lab was energies and the energy principle. We use position and update velocity formulas separately instead of using kinematic equation, because kinematic equation cannot be used for non-constant forces. And that is everything. Thank you for your time.